Alright guys, so in this video we're talking about surface area of prisms and cylinders. And a reminder, we talked about prisms, and that's the kind of polyhedron that has two congruent faces called bases. And when we talk about surface area of a 3D figure, really we're just talking about the sum of all of its faces. Okay, so think of this box. So you see this blue and red and green box. If I were to unfold that and lay it out flat, that's what the net is. The net is like if I took a box and unfolded it and laid it out flat. That's what it would look like. So you see we have just 6 rectangles that we would add together to be the surface area. So we also are going to talk about cylinders, and remember, cylinder is just a special type of prism. It's a prism with circular bases. So reminder that we have a radius of the base, and the part that is curved, the height part, the green part, is called the lateral surface. The height goes from circle to circle. All right, and if I were to unroll that, then I would get 2 circles and this big rectangle when I unrolled it. That's what the net would look like. So let's talk about the formulas. How do we actually find the surface area? So the surface area formula is right here. And I want to discuss how we actually know that that's what the formula is. So if we take each piece of the surface area formula, remember that surface area is just adding up. Like if I was adding up those 2 green triangles, the 2 red triangles, and then the 2 blue triangles, that would be the surface area. But another way of thinking of it is if I just designate, I'm going to designate the blue ones to be the bases. So this is a base and this is a base. Okay, so if I do 2 times the area of the base, so when I am using capital B in my formula, I am talking about the area of the base that you have designated. All right, so how would I find the area of this base? Well, I would just do length times width. All right, so I'm going to be doing 2 times those since there's 2 blue triangles. And then it says I'm going to be adding the perimeter times the height. So let's think about that. If I was doing the area of the green and the red rectangles, I would do base times height, base times height, base times height, and base times height. Notice that all of these have the same height. And that's what we call the height of the prism, because that's the distance between those 2 bases, those 2 blue rectangles. Now these small little bitty b's, these bases, these are not the base, like that's not the big base that we were talking about with the blue rectangles. We're just talking about this length and then this length, this length, and this length. So if we think about how those came to be when we laid this out flat, it came from this box. And keep in mind that green, the base of this green rectangle is right here. And then the base of this red rectangle is right here. And then we had another base of the green rectangle, which that's this distance. And then I had another red rectangle, which is over here. It's hidden, you can't see it, but it's over here. So notice all I did was I traced around the edge of the blue rectangle. And another way of saying that is just perimeter. So all of these little bitty b's, small lowercase b's, all of those are essentially going to be the perimeter of the base. So that's why we say, rather than doing each of those individually, we're going to say that's the perimeter of the base. And then instead of doing each of those individually, we're going to do times 1 single height, because they're all the same height. So that's where we're getting the perimeter and then the height in our formula. So if I scroll down here, I want to make sure we understand that the height, when we say height, that is the distance between the 2 bases. And when we say the perimeter, we are talking about the perimeter of the base, the distance around the base. So if we look at this first example, we have a rectangular prism. And remember, in a rectangular prism, any of the sides we can call the base. But let's just say I'm going to call the blue rectangle of the base. So this is the base, and then this top part is the base. Okay, those are the two bases. So if I'm going to do capital B, that means I'm doing the area of the base. Well, how do I find, here I'll draw the base here. It's 3 by 5. How do I find the area of that? I'm just going to be doing base times height, right? So that would be 3 times 5. So for my capital B, I'm doing 3 times 5, which is just 15. Then I have to look at the perimeter. So if I go back to the base, I have to think about what all sides are. Well, if this side's 3, then this side is 3. And if this is 5, then this is 5. So for perimeter, all I'm going to be doing is adding up all of those edges. So that's going to be 3 plus 5 plus 3 plus 5. So if I add those together, I'm getting 16. And then the height is the distance between the two bases. So if I go from this base to this base, that is the height, which is 8. So we have all of the pieces we need for our formula. And so now we can plug those numbers in. So surface area is going to be 2 times B, and we said B was 15, plus my perimeter P, which is 16, times the height. So this is going to be 30 plus 128, and that gives me 158. So the surface area of this rectangular prism is 158 inches cubed. All right, let's look at number 2. This is a triangular prism because the base is in the shape of a triangle. Okay, so that's one of our bases, and then that triangle in the background is also one of our bases. So I'm going to draw that out so we know that's what we're dealing with. So notice that they label the left side 3, the bottom 4, and even though they don't have it in the front part, the hypotenuse is 5, so that's good to know. So if I wanted to find capital B, that's the area of the base. So remember, to find the area of a triangle, we're going to be doing 1/2 base times height. So I'm going to be doing 1/2. The base of this little triangle right here is 4, and then the height of that little triangle is 3. So for capital B, I'm doing 1/2 4 times 3, which is 6. So capital B is 6. All right, for P, the perimeter, I'm just going to be adding up all of the sides. So 3 plus 4 plus 5, which gives me 12. So the perimeter is 12. And then the height is the distance between those two bases. So if I connect the front triangle to the back triangle, that's that distance, which is 2. So my height is 2. So now we have all the pieces to do the surface area formula. So we're going to plug those in. So I'm doing 2 times capital B, which is 6, plus P, which is 12, times the height, which is 2. So that gives me 12 plus 24, which equals 36. So my surface area of this triangular prism is 36 meters cubed. All right, let's look at the cylinder. Now, what's different about a cylinder? Well, nothing really. It's still a prism, it's just the base is a circle. Okay, so they told us that that whole diameter is 12. So remember, if the whole diameter is 12, then the radius is 6. So each of those is 6. So if I find the capital B, that's the area. Area of a circle is pi r squared. So I'm going to be doing pi times 6 squared. So that's pi 6 squared, which is 36 pi. And I'm just going to leave it like that. I'm not going to multiply by 3.14 yet because I don't want a decimal. We're going to round at the very end. All right, so for P, the perimeter. Now for perimeter of a circle, remember we don't call it perimeter, we call it circumference. And that formula is 2 pi r. So for perimeter, we're going to be doing 2 times pi times my radius, which is 6. So that's going to give me 12 pi. Remember, perimeter is the distance around. So that's the circumference. All right, and so our height, the height goes from circle to circle. So if I start at this circle and go to this other circle, that is 10. Okay, so my height is 10. So I have all my pieces to do this surface area. So my surface area is 2 times capital B, which is 36 pi, plus T, which is 12 pi, times 10. So if I multiply those together, I get 72 pi. These I get 120 pi. Now if I add those together, I have 192 pi. And now I can hit my little button that gives me the decimal, and that's about 603.2 feet cubed. So that's my surface area. So if it asked for a decimal, we would put that. If it wanted an exact answer, we would put 192 pi. That is the most exact answer. Remember, that's not rounded. Okay, our last example. Now this one is a hexagonal prism. So our base is a hexagon. Okay, so remember last class we talked about how do we find the area of a regular polygon. And we said that we do 1/2 the apothem times the perimeter. So, oh my goodness, that was a lot of work. So let's come back to that part. Let's do the easier parts first, and then we'll do the area of that base. So I'm going to skip capital B for right now. I'm going to do the perimeter of the base. Now, do you notice that it says that each of these is 6? So for the perimeter, I'm just going to be adding up 6 6s. So if you want to write them out, 1, 2, 3, 4, 5, 6, that would give me 36. So P is 36. And then the height goes from hexagon to hexagon, so from the front to the back. So that's the height. So that's 8. Now let's get back to the capital B. Remember when we did area of a regular polygon and we only knew the sides, we had to know what this central angle is. So for the central angle, we always do 360 divided by how many sides there are, and there's 6 sides. So that means that this central angle right here is 60 degrees. Now I want to use that little triangle because remember the apothem goes right down the middle. So I'm going to draw a larger version of that. So if I cut that down the middle, remember that central angle gets cut in half as well. So this little bitty angle is 30. Okay, and this is my apothem. Also remember when I use that apothem, it cuts that triangle in half. This is no longer 6, this is 3 and 3. So the base of this triangle right here is 3. So if we are trying to find the apothem, we have to use trig. So reminder, label your sides. So this is the hypotenuse. All right, this is the opposite side. This is the adjacent side. Okay, so we're going to set up our equation. We need to use the 3 and the apothem. So I'm doing opposite and adjacent, which is tangent. Tangent of 30 equals 3 over a. And when I do the tangent of 30, it gives me square root of 3 over 3. So I'm going to keep it like that. I don't want a decimal yet. Remember, we're going to try not to round as much as possible. So now I'm going to cross multiply. So I'm going to get a times the square root of 3, and then on the other diagonal I get 9. One more step, I have to divide by the square root of 3 to get a by itself. So I'm going to get a is, when I do that, I'm going to get a is 3 times the square root of 3. Whew, so we have all of that just to get the apothem. Now, do we know the perimeter of our hexagon? Yeah, we do. Didn't we already do that when we were counting up all the sides? So we know that the perimeter is 36 already. So I'm going to go back to my area formula, and I'm going to plug in what I know. So I have 1/2 times 3 root 3 times my perimeter we said was 36. So if I do all of that, ooh, my calculator is not letting me have an exact value. It's saying that it's 93.5. Okay, so my area of my base, that is my capital B. So I'm going to transfer that 93.5 all the way up here to my capital B. Okay, so in this one we had a lot more work. And now we have all of the pieces we need to do the surface area. So we've got one more formula to do. So let's scroll down here and start our surface area formula. So we have surface area is 2 times capital B, which we just said was about 93.5. And then our perimeter was 36. And our height was 8. So I'm going to get 187 here and 288 right there, and I'm going to add those two together, and I'm getting 475. And so this is a rounded value. So I'm probably going to put these squiggle ones since that's rounded. Okay, so my surface area is 475 meters cubed. All right, so that's how we do surface area of prisms and cylinders, and we'll do more practice in class.